All right, here we go. Unit 4, Section 5. No, I know you're thinking to yourself, whoa, what happened to Section 4? Take it easy. We just skipped it. It'll be all right. We're moving on to Section 5, though. And we are proving a quadrilateral is a parallelogram. So just a review quick from the first section of this unit. A parallelogram has opposite sides that are parallel. That's just the definition. Opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. So let's make a list going the other way. So if we have a quadrilateral and we have opposite sides parallel, try that again. Opposite sides are parallel. Then we have a parallelogram. If we have opposite sides congruent, then we have a parallelogram. If we have opposite angles congruent, then we have a parallelogram. The fourth one, if we have one pair of opposite sides parallel and congruent, then we have a parallelogram. So one pair of opposite sides that are parallel and congruent. It's got to beat both. Consecutive angles supplementary. And the last one, if we have, diagonals that bisect each other, then we have a parallelogram. So we have 6 ways to prove that a figure is a parallelogram. So let's just go down below here. Is it a parallelogram? Yes or no? And then we got to list one of those 6 reasons as if it is. So is this a parallelogram here on the left side? Yes, it is, because opposite angles are congruent. And I should probably add that it has to be both pairs. So we have 115, 115, we have 65 and 65. So both pairs have to be congruent there. Over here on the right side, do we have a parallelogram? Yeah, we do. Because both pairs of opposite sides, well, come on, are congruent. If you scroll back up to the list, that would be number 2 here. Opposite sides are congruent, both pairs. Is the quadrilateral a parallelogram? Yes or no? Here we go. This is no. Why? Well, we would need to know that these sides are congruent, or congruent. We would have to know that these sides are parallel. That would be one way. So we have opposite sides parallel. Or number 4 here, one pair of opposite sides has to be parallel and congruent. So if I just knew that these sides were congruent, then that would also be enough. But no, as it sits right now, we have one pair of opposite sides parallel, a different pair that is congruent. They would have to be the same. How convenient. Here to the right, we can say that yes, because we know that these sides are parallel, and because they're both 30 meters, they're congruent, so that would be number 4 up here. One pair of opposite sides is parallel and congruent. And holy cow, this can't be the last one, but it is. Is this a parallelogram? Yes, This is one you don't see too much, but the diagonals bisect each other. And again, that word bisect just means cut into two congruent parts. So these are congruent because they're getting split here. These are congruent because they're getting split in the same spot. So the diagonals